Hey guys, let's have a look at this question. So in this question, you need to find out the equivalent capacitance between A and C, right? And to solve this question, we'll be making use of some ideas of symmetry and some ideas of labeling of potential as well, right? So let me talk about the symmetrical idea first. So if I talk about the symmetrical idea, you can see that this entire diagram is symmetrical about A and C. So that means if I fold the circuit about this line, this point and this point will have the same potential, and this point and this point will have the same potential, right? So that's one idea I'll be using in this question. Points 1 and point 2 will be having the same potential. Point 3 and point 4 will also be having the same potential, right? Is one idea we'll be using in this question over here. Now, on this basis, let me start. Also, point B and point D will also have the same potential. Points B and point D will also be having the same potential. Okay, so on this basis, let me now start labeling potentials. So let me assume potential at point A is E. So potential at point A is E. Potential at point C is zero because that's how we are imagining the battery to be connected, right? Okay. Now, if your battery was connected, if your battery was now connected in this way, I'll assume some charge flow happens from here to here. Okay. And some charge flow happens from here to here. Okay. Now, if the battery was connected in the reverse way, whatever charge flow, if I had Q charge flowing over here, if your battery is now connected in the reverse way like this, if your battery is now connected in this manner, then in this case, I'll again have the same Q charge flowing in here and here, right? And the idea behind this is now, because I have the same charge going into the capacitor, I must have the same potential difference. So potential difference from here to here is the same as the potential difference from here to here. And the sum of these potential differences should be equal to E right now. So that means potential at this point will now become equal to E by 2. And because these two are now symmetrical, I can use the same argument and say that potential at this point will now become equal to E by 2, right? Okay. So continuing forward with our symmetry idea, let me assume that the battery gives some charge over to this branch as well. Right. Now, whatever charge the battery gives to this branch, again, if I use the idea of symmetry over here, when the battery is connected in the reverse way, like if the battery is connected in this manner right now, then the battery will give the same charge over here as well, because the circuit looks the same when your battery is connected in the reverse manner as well. So that means charge flow happening from here to here is the same as charge flow happening from here to here, which means potential difference between these 2 points is similar to potential difference between these 2 points, right? So with that kept in mind, if I say now that potential at this point is X, potential at this point will be equal to E minus X, because I must have the same potential difference from here to here and here to here. Okay, and now if this potential is X, then this potential will also be equal to X because these two are symmetrical. If this potential is E minus X, then this potential will also be equal to E minus X, right? Now we realize that we only have one unknown potential, and that one unknown potential which we have is X right now. So to find out that X, will write a nodal method equation. And the way I'll be writing nodal method equation is I'll assume charge flow is happening this way into that junction. So what's a nodal method equation in this case? A nodal method equation in this case will be equal to, so charge flow in this branch will be equal to C into E. So that C value is, let me say, C itself. And E potential difference is E minus X. So C into E minus X plus charge flow here will be equal to C into X minus X. So do you realize that this capacitor will not get charged? So that's useless anyways. So that will be equal to 0 anyway. So I'm writing it as 0. Charge flow from here to here will be equal to C into E by 2 minus X. And charge flow from here to here will be equal to charge flow from this branch to this branch will be equal to C into E minus X minus X. So that will be equal to E minus 2X. That will be equal to E minus 2X. And now this will be equal to 0. Right, so from this you can find out what the value of X will be equal to. Solving this equation will get, eliminating C everywhere, I'll get E minus X plus E by 2 minus X plus E minus 2X is equal to 0. So I'll get 5E by 2 minus 4X is equal to 0. So I'll get X to be equal to 5E by 8. So that means potential at this point will be 5E by 8. Potential at this point will be equal to 3E by 8. And now that I know potential at these points, now I can try to find out what will be our effective capacitance. So to find out effective capacitance over here, I'll be making use of the idea that total charge given by the battery is equal to C effective into EMF. So C effective will be equal to total charge given by the battery divided by E. Right? And now what's your total charge given by the battery? Your battery is giving charge to this branch, this branch, this branch, and this branch. These are the 4 branches like charges entering from the battery over here and splitting into 4 branches over here. So what will Q1 value be equal to? Q1 value will be equal to, so now I know this potential difference is E by 2. So this is Q1. So Q1, the charge flowing into that capacitor will be equal to C into E by 2. What will be the Q2 value? Q2 value is charge again going into this capacitance. So that will be again be equal to potential difference is E by 2. So Q2 value is also equal to CE by 2. Right, now we found out this X value is 5E by 8. So how much charge is going into this capacitor? That's your value Q3. Your Q3 value will be equal to E minus 5E by 8 is your potential difference. So that is 3E by 8. So your charge flowing there is C into 3E by 8. And similarly, Q4 is charge flowing into this capacitor. Again, this potential difference is 3E by 8. So charge on that capacitor will be equal to 3CE by 8. Right. So making use of this, your Q is equal to nothing but Q1 plus Q2 plus Q3 plus Q4, which is CE by 2 plus CE by 2 plus 3CE by 8 plus 3CE by 8. And this divided by E will be your C effective. So that will become equal to C by 2 plus C by 2 plus 3C by 8 plus 3C by 8. So this will become C plus 3C by 4. That is equal to 7C by 4. So your effective capacitance in this case is equal to 7C by 4. And C value is equal to 4 microfarad. So this will become equal to 7 microfarad. Right? Hopefully this question made sense. See you guys in the next question.